Okay, so this is your first lesson for your chemistry unit called Chemical Reactions Physical Science. I want to stress here that this is a much quicker run through than you would receive if you were actually in the class. So I'm going to do this hopefully in about 30-ish minutes, 25 minutes. This took the entire period in class. There were many more examples, many more analogies, some discussion, all that stuff, and you are missing all of it. This is just the basic info. So start by defining chemistry. So what in the world is chemistry? We've got three important points here. Study of composition, structure, and properties of matter. Composition just means what it's made up of. Structure is sort of how that physically looks, where things are and stuff like that. And properties include things like what it wants to bond with, but also, is it shiny? Is it hard? Is it malleable, meaning you can mush it around in your hands? Those sort of things. So all of those things are included in the study of chemistry. It includes the study of changes that matter undergoes. So what happens when you stick it with something else? What happens when you heat it up? What happens maybe when you cool it off and stick it with something else? So those types of things are included in chemistry. It's in every single aspect of our life. It's maybe a little bit harder to see around you than physics is, but only because it's on a smaller, usually, level. So we're talking about molecules and atoms that you don't walk around and see with your naked eye. Whereas structures of buildings and things like that, you can. Properties of matter. This is an important definition. You should start a definitions page for your chemistry section just because it's a super easy way to keep that all in one spot, and those are very easy questions for teachers to ask on tests. So I recommend you start a definitions page. First definition I would throw down there is what matter is. Anything that has mass and takes up space. I have not ever seen a different definition of matter than this. So it shouldn't even change by one or two words between teacher to teacher. It's unlikely that you will encounter anything except for exactly that. Two important points of matter: has mass, takes up space. Next up, matter is going to have a wide variety of physical and chemical properties. And so what that means, the physical stuff there, how it looks, whether or not we can bend it or twist it or shape it, things like that. And then the chemical properties, what it wants to do when it combines with other things, or does it even combine with other things. Every single bit of matter that is different from another piece of matter so every different substance is going to have slightly different physical and chemical properties, or maybe wildly different physical and chemical properties. You've got a fancy little picture there. The analogy I used in class was the concert or like a mosh pit, things like that. Solids are really tightly held. They don't move around very much. If you get them under a microscope, they might be wiggling a little bit, but they're not moving around from place to place. They're going to hold their shape and be very, very closely packed in. A liquid is a little bit different. It's going to be closely packed in, but its shape is obviously going to change. We've got different physical properties there. It can be poured out and things like that. But if you got looking at a molecular level, the molecules are going to be moving a little bit faster and a lot more freely than in a solid. They're going to go from place to place. And then a gas, they're going to be a lot more spread out. So this is like when somebody pulls the fire alarm and there's only a few stragglers left in the building. You've got molecules that are very, very spread out, and they're moving very quickly. Classifications of matter. We can look at the physical properties classify matter. So that would be things like what its appearance is, which just means what it looks like. So physical properties. We can look at appearance. We can look at composition. So what it is actually made of, what makes it up. Can we separate that out into its parts, or can it be broken down easily? So the classic example here is the snack mix. That is something where you can physically see different things. You've got nuts and raisins and Doritos and whatever it might have in there. and is very easily separated out. 2 words I would also add to your definitions sheet. They are homogeneous and heterogeneous. Homogeneous means it looks the same throughout. It's going to have a uniform appearance. You're not going to see different items in there. Whereas heterogeneous, you've got the snack mix example picture there to the right. You've got different things in there. So clearly you look at that and you've got like the whatever honey-coated nuts and the weird long nuts that don't taste very good, and then you got pistachios and whatever else you got in there. Can you see different parts, or does it have a variable appearance? Milk, you're never going to look in your milk before you drink it, hopefully, and see different things floating in there. If you do, probably don't want to drink that. So that was homogeneous, looks the same throughout. Heterogeneous, there's different things. Those are important definitions. Composition. So physical separation through filtering or straining, or potentially by just heating it up and boiling it. And then a chemical separation is requiring a chemical reaction, and that could be something like decomposition, for example. It could be something like the picture to the left there is a combustion reaction, so we're going to get heat and water and carbon dioxide and maybe carbon monoxide as a product of that. Classifications of matter. So all matter can be classified as an element, compound, or mixture. Those 3 things. And now we're going to add 3 more definitions to that page, because elements, our first one, has only one type of atom. An atom is different from a molecule. An atom is different from a molecule. A molecule is 2 or more things stuck together, 2 or more elements stuck together. An atom is a single atom of one element. So an element is just composed of one type of atom. It cannot be broken down into simpler substances. And usually somebody pipes up here and says, well, what about if we steal some electrons and we give it a charge? That is not changing the substance. You are just giving it a charge. So you're stealing some electrons or giving some electrons away, maybe. You are not changing what it is. So it cannot be broken down into pieces, into different things. So that's an element. Elements will always be homogeneous in appearance. You will never run into copper or silver or anything like that that looks like anything but copper or silver. A compound has 1 or more elements. When you look at that fancy periodic table that you got, any 2 squares on there, if they stick together, that will be a compound. Can only be broken down by chemical reactions, so it cannot be physically separated. We're not getting out the knife, we're not running it through a filter or anything like that to separate it out into its 2 elemental parts. That is not possible. It has chemically combined, and so it needs to be chemically basically broken down after that through a chemical reaction. It'll be homogeneous in appearance as well, so it is always going to. So the example here is most common compound you run into every single day is water, H2O. So we've got hydrogens and we've got oxygens. They're stuck together. We are not going to be able to stick a knife in the glass of water and separate out hydrogens and oxygens. And it always looks like water. There isn't, hopefully, things floating in it. A mixture. That'll be many elements or compounds stuck together. These are not pure substances. This can be easily separated through physical processes, so things like filtering or boiling or melting, maybe, stuff like that. And it can either be homogeneous or heterogeneous. So it can look the same or it can look different. And the example I use for that one is you've got a deck of cards. If you flip those cards over so you see all the numbers and the face cards and all that sort of stuff, you've got a heterogeneous mixture. Clearly the kings look different from the 6s and 8s and red cards and black cards, all that sort of stuff. But if you flip them over so you see the back of the cards, now all of a sudden they're homogeneous in mixture. It's still different elements or different compounds making that up. We've got all the 6s and the kings and the 9s and whatever. But it can look both ways. This can be easily separated out through a physical process, like I said, and that is a mixture. So you've got your 3 definitions added. Anything you see highlighted in pink on this is important. So matter can change in 2 ways. We've got 2 kinds of change, physical and chemical change. If I was in your position, I would probably start a sheet, divide it in half the sort of tall way, and into two columns, and I would have physical changes on one side, and I would have chemical changes on the other, and I would just start a running list of words to look for to identify physical and chemical changes. Change of state is the first one I would put in the physical column. So a change of state is always a physical change. So melting, freezing, evaporating, condensing, all those things, a change of state, going from a solid to a liquid or a liquid to a gas or back the other way, is going to be a physical change. Super critical, absolutely throw a highlight on this, flashing lights important, is that no new substance is produced. You do not get new things with a physical change. So if you're analyzing something to see if it's physical or chemical, you want to ask yourself, is there something new at the end? And if there is a new substance, it is not physical. It would have to be chemical. So examples of this are cutting up wood, tearing up paper, all that sort of stuff. I gave you the change of state examples before. Super critical, like I said, no new substance formed, and you can actually get original materials back. And it's usually fairly easy to get the original materials back. Chemical change. You always have a new substance. Always. It's different from what you started with. So you might start with hydrogen and oxygen, two gases separate, and all of a sudden it turns into water. You can't separate out hydrogen and oxygen that make up the water very easily at all, and so you've got a chemical change. It has properties that are different, so meaning its boiling point, whether or not it's malleable, what it looks like, all those sort of things are going to be different from what you started with, and you cannot get the original materials back easily. In some cases, you can't get them back at all. That's a chemical change. Classic example is burning matches. You strike the match, it burns, you let it burn to the end. You are never going to be able to get back a brand new match that you could strike and light all over again. It'll never happen. You've got a combustion reaction, it has turned into completely different things, and now some of those things have evaporated into the atmosphere, and you can't get it back. Okay, these are not guarantees that you will have a chemical change, but they're a really good indicator that you will have a chemical change. So generally speaking, these indicate chemical change, but not always. Color changes. That can usually mean a chemical change. Heat or light is given off. That's usually a chemical reaction. Gas released is usually a chemical reaction. Solid precipitate. Precipitate just means a solid. That's all it is. Those words mean the same thing. Is formed in a liquid, so we mix two liquids together, and all of a sudden one turns into, or we get little solids in the bottom of it. That is going to be a chemical reaction. And then the change is difficult or impossible to get back, to reverse. That's generally speaking going to be a chemical change. Super critically important, you always get a new substance with a chemical reaction. Always. New substance is formed, it must be chemical change. That's the end of today. So that is what you missed if you missed our first lecture on chemistry.